Hello and welcome once again. Today we are continuing with our discussion on linear definite equations. Recall that in the last session we saw that a linear definite equation in two variable of the form ax plus by is equal to c with a and b positive is solvable if and only if the GCD of a and b divides c. And we also observed that in the case that there exists at least one solution, that is GCD of AB divides C, we can find infinitely many solutions, and we saw that how the solutions actually look like. We actually found one solution for the linear definite equation in the last sessions using Bezout's identity method. Now we are going to see another method using which we will be solving the linear definite equation in two variables using a method suggested by Euler. Of course, this method is also applicable if and only if the GCD of AB divides C. Now we are going to see Euler's method for solving a linear definite equation in two variables. Before going to see how Euler's method works for solving two variable linear definite equations, we will quickly recall the important fact that we learned in the last two sessions. So the result we have is this: a linear definite equation ax plus by is equal to c with ab greater than 0 is solvable if and only if GCD of ab divides c. Note that this ab greater than 0 restriction is not that strict, because we can, even if we have ax plus by, if one of them is negative, suppose that b is a negative integer, then we can take ax plus minus b into minus y equal to c. In that case, in that way we can make a and b look like positive integers. So that is not actually a serious restriction. So the condition for the solvability of ax plus by is equal to c is that GCD of a and b divides c, and if x naught y naught is a solution, one solution we found, and if the GCD is denoted by d, then the set of all solutions of this definite equation is nothing but it's equal to the set of all x naught plus b by d into q and y naught minus a by d into q, where q is any integer. So this is the most important thing that we learned about solutions of two variable linear definite equations. And we know that using the Bezout's identity we can find one solution for this, and then we can find all the solutions using this result. But now, instead of using Bezout's identity, we are going to see another method suggested by Euler. There is a terminology about which we should be aware of. This x naught b by d q, x naught plus b by d into q, y naught minus a by d into q. This is known as the general solution of the linear definite equation ax plus by is equal to c, and the x naught y naught that we are finding, this is known as a particular solution. So we have general solution and particular solution. Now we will see Euler's method using a problem. The question is the following: solve the linear definite equation 10766 plus 2076y equal to 3076. Suppose we label this as equation 1 by Euler's method. Okay, in Euler's method what we usually do is we will consider the variable with the least coefficient. So here we have variables x and y, and the variable with the least coefficient is x. So the first step we should take, considering the variable with least coefficient, that is 1076, and that's a coefficient of x. So 1076x, we are going to move the term with the larger coefficient to the other side, minus 2076 y plus 3076. Now we are going to use division theorem in the following way. And before that, we should actually check that if this linear diophantine equation 1076 plus 2076 is y equal to 3076 has a solution or not. That we need to actually check even before starting. That's very important. We haven't checked that. So what is GCD of 1076 and 2076? 2076, find 2076, 1076 GCD. This is equal to 1076 into 1 plus what is remaining is 1000. Now 1076 is equal to 1000 into 1 plus 76. Now 1000 is equal to 76 into you just check. I have found it to be equal to 13, and so it is 988. Therefore the remainder is going to be 12. Now 76 is equal to 12 into 6 plus 4. Now 12 is equal to 4 into 3 plus 0, and therefore this is the GCD. And now the GCD, will it divide 3076 is the initial check that we have to perform. Now 76 is a multiple of 4, and for checking if a number is a multiple of 4 or not, it is enough to check whether the last two digits is a multiple of 4 or not, and therefore 3076 turns out to be a multiple of 4. 4 divides 3076, therefore equation 1 has a solution, that is guaranteed. Okay, now we are trying to find out that solution. For that, we are keeping the variable with smaller coefficient on the left side, moving the other variable to the right side. Now we are going to perform some division this following way: 76y by 1076 plus 3076 by 1076. Now we need to find 2076 is equal to 1076 into how much that we have actually already found. It's going to be just 1 plus 1000 is the remainder. Therefore this is going to be, we can write this as 1076 plus 1000. So minus of 1076 into 1 plus 1000 into y divided by 1076. Note that since we are assuming that there exists a solution, this x and y we are considering to be integers. There exists x and y satisfying this equation because the GCD of the coefficients divide the right side. And plus now 3076 that is going to be by division theorem. 3076, this is division theorem. 3076, this is also division theorem. 3076 is equal to division theorem. 3076 is equal to 1076 into 2 plus 924, that's the remainder. So this is going to be 1076 into 2 plus 924 divided by 1076. Now 1076, therefore this is just y. 1000 by 1076 y. 1076 into 2 by 1076, that is equal to 2. 924 by 1076. These are the remaining things after a division and leaving the rational part just like that. So this is equal to, or x is equal to, here we get minus y plus 1000 by 1076 y. Minus y plus 1000 by 1076 y. Not just that, 1076 into 2 by 1076, therefore this is 2 plus what is the remainder? 924 by 1076. Now this is equal to minus y is an integer, 2 is an integer, x is also an integer because we know that there exists solution for the given LDE. Therefore 1000 by 1076y plus 924 by 1076 must be an integer. I will just club them. Minus y plus 2, 1000y plus 924 by 1076. So this is an integer. This is also an integer, therefore this must be an integer. 1000y plus 924 by 1076 is an integer, and we are going to give it some name. This integer we are going to give it the name. Suppose that we are calling it as t. This is t. Now we multiply this 1076 into t. So 1076 into t is equal to 1000. Is this 1000y or minus 1000y? This is minus. Sorry, here there is a minus sign. This is minus. This is negative. This is negative. This is negative. 1000y plus 2924 or 1076t plus 1000y equal to 924. We are going to repeat exactly the same procedure. What is the procedure? Consider the variable with the least coefficient. What is here the variable with the least coefficient? So same procedure we are following again and again. Again, consider. Okay, we will just label this as linear diophantine equation 2. Now, even before considering the label, probably we should check whether this LDE is solvable or not. So, what is the GCD of 1076 and 1000? We have to find. Next step is to find GCD of 1076 and 1000, and this is equal to, okay, we are again going to use Euclidean algorithm. 1076 is equal to 1000 into 1 plus 76. So 1000 is equal to 76 into, okay, that we have already done. See, 1076 is equal to 1000 into 1 plus 76. So see that the GCD of 1076 and 1000, we have already seen that there is going to be a GCD of 2076 and 1076. Therefore, that's going to be equal to 4. So there is no need to check all these things. So even this is not necessary. So we have already done this. We have already found that GCD of 2076 1076 is going to be equal to 1076,000. So this is going to be equal to just 4. And does 4 divide 924? 24, yes. 4 divides 924. Therefore, the LDE2 is solvable. That is guaranteed. Therefore, there exists integer t, integer y, such that equation 2 is satisfied. So we can find integers t and y satisfying. So there exists integers t and y satisfying 2. Okay, what is the equation? 1076 plus 1000y. Okay, I'll just select that. 1076 plus, copying it, pasting it to the next page. Okay, it's placed here. Now, what is the same step we are going to follow? Consider the coefficient, the variable with least coefficient. What is that? Here it is 1000. So 1000y equal to minus 1076t plus 924. Again, divisioning, y equal to minus 1076 t by 1000 plus 924 by 1000. Here there is no division to perform. This is 1076 is in terms of 1000 is going to be 1000 into 1 plus 76. Therefore we can split it as, this could be splitted as minus 1000 t plus minus 76 t divided by 1000 plus 924 by 1000, which is equal to minus 1000. Therefore this is just minus t plus minus 76t plus 924 by 1000. Now we know that y is an integer, t is an integer, so minus t is an integer. Therefore minus 76t by 924 by 1000 is an integer. So we will call that as u. We are keeping on bringing newer and newer variables here. Put u equal to minus 76t plus 924 by 1000. Now bring 1000 to the left side and rearrange. So 1000 u plus 76t is equal to 924. Consider, and what about this solvability of this? What about GCD of 1076? See that GCD of 1076 is nothing but GCD of 1000 and 1076. That is equal to GCD of 1076 and 2076, which is 4. So this GCD is 4, and 4 definitely divides 924. So this linear diophantine equation 3 is solvable for integers u and t. Now again consider the variable with a smaller coefficient. What is that variable? Here it is 76t. So t equal to, by rearrangement, 1000 u by minus 1000 u plus 924 by 76. 924 probably has come even here. No, it is not here. Okay. So minus 1000 by 76, that minus 1000 is already there. 1000 is equal to 76 into 13 plus 12. So t equal to minus 1000 is 76 into 13 plus 12 minus sign. What is the variable? It's u by 76 plus 924. It's going to be 12 times. So 924 is equal to 76 into 12 plus another 12. Therefore this is 76 into 12 plus 12 by 76, and this is equal to 76 minus 76, sorry, minus 13 plus 12u by 76 plus 76 into 12. Therefore this is just 12 plus 12 by 76, and therefore again we get minus 13. Oh, here there is a u. Here also we have a u. So minus 13u plus 12 plus, here it is actually a minus sign. Minus 12u plus 12 by 76. Now the same argument as before. T is an integer, minus 13u plus 12 is an integer, so minus 12u plus 12 by 76 is also an integer. So put EQRSTU v, okay, v equal to minus 12u plus 12 by 76, and then again rearranging. Therefore 76v plus 12u equal to 12. Now consider the variable with the smallest coefficient, that is equal to, that is the coefficient is 12. Therefore u equal to minus 76v by 12 plus 12 by 12. Okay, even before that, we have already seen that 7612 we have to check the GCD, but 7612 the GCD is already here. 7612 the GCD is nothing but it's equal to GCD of 76,000, that's equal to GCD of 1076, that is 1076, and 2076, that is again 4. The GCD is 4. The GCD of 76, this is right, 76 12 equal to 4, and 4 divides 12. Therefore this has a solution u and v integers. Therefore this is solvable for integers u and v. Now this is equal to minus 76, 12 into, that is equal to 12 into 6 plus 4 v by 12 plus 1 is equal to minus 6v plus minus 4 by 12 v plus 1. This is equal to minus 6v plus 1 minus 1 by 3v. Now u is an integer, minus 6v plus 1 is an integer, therefore minus 1 by 3v is also an integer, and therefore 1 by 3v is an integer. So 1 by 3v we will put, or let we write the symbol w is equal to 1 by 3v, or v equal to 3w. Now see that we got an expression involving just two integers, and this is quite a simple expression to solve by hand, because if you put any value for w, we will get a value for v. So to get a simplest possible value, because we need a particular solution, to get a particular solution we will choose some value for w which is the simplest possible. So we can choose w equal to 0 to get a particular solution. Let w equal to 0. Then what is the value of v? Then v will be equal to 3w, then v is equal to 0. v equal to 0. So if you put the value of v in u, so u is nothing but minus 76v by 76. Okay, any expression we can use. If you put v equal to 0, minus 6v 0, minus 1 by 3v 0, therefore u is 1. Therefore u equal to 1. Now what about t? T we have found to be, now u is 1, t is therefore minus 13 plus 12, minus 13 plus 12 is minus 1. So this is minus 12 plus 12 by 76, therefore t is equal to, therefore t equal to minus 1. If t is equal to minus 1, what is the value of what is the variable before that? U. T is minus 1, therefore this is minus 76 into minus 1, therefore this is 76 plus 924, that is equal to 1000 by 1000, that is 1, therefore u is 1. No, but u we have already found, so we have t here. So using the value of t, okay, we have to find y, not t. So what is the value of y? T is already obtained to be equal to minus 1. So y is equal to minus t, therefore minus minus 1, that is 1. This is 76 plus 924 by 1000 once again. So this is again 1. So minus 1. Sorry, this is 1. This is also 1. Therefore, it's going to be the value of y is going to be equal to 2. Therefore, y equal to 2. We are substituting everything backward. Now, if y is equal to 2, we will get the value of, what is the value of x? X is equal to Okay, y is 2, x is equal to minus 5 plus 2, therefore this is minus 2 plus 2, that is 0. Here it is 2, therefore minus 2924, which is going to be 1076. Minus 1076 by 1076, therefore this value is going to be equal to minus 1. Therefore x is equal to minus 1. So we found a particular solution, x equal to minus 1. Therefore a particular solution is minus 1, 2. Now to find the general solution, we can use our previous result. So the remaining thing is an exercise. Find the general solution. So for finding the general solution, we need to just depend on this expression x naught. X naught we already got to be equal to minus 1. Y naught we got to be equal to 2. We know b, we know d, we know a. All these things are not, therefore we can easily find the general solution that is left as an exercise. So we now have two ways to solve or find particular solution for two variable linear Diophantine equation. One is using the Bezout identity and the other one is Euler's method, which is not using Bezout identity but only uses division theorem. And this actually completes our discussion on two variable Diophantine equations. And next we move to Diophantine equations with more than two variables. We are stopping the session with this. Thank you.